There we go. Hey, everybody.
Hello,
How are you all today?
I'm good. I couldn't get anything.
Couldn't get anything. What do you mean?
Like I had I had no tablets, so I was thinking this would be okay.
Yeah, that should work. One of those packets of the gel.
It's not gel, it's like powder.
Oh, that's even better. You don't have to crush it yourself.
Oh.
Yeah,
I can't do it today, but can I do it at home? Will you send
absolutely. Yes, I was going to say that if you're not able to do it today, you can use the instructions on the lab sheet that I sent you and do it yourself. But you'll see how to do it here. So yeah, that'll work well. Yep, great.
I'm
All
gonna
right.
have to do it at home too.
Okay,
My
that's
dad didn't
fine.
want me making a mess on my desk.
Okay, that makes sense. That makes sense. And the everything wipes up except that the iodine. The iodine will stain anything that you touch it to. So you want to be careful when you're using iodine. This is what iodine looks like right there. And it's that brown color and it definitely stains everything, kind of an orangish brown. So be very careful. All right. Anybody have any questions before we get started? All right, let's begin. All right. So we have a small class today. Is anybody doing the experiment along with me? Okay. All right, great. That'll be wonderful. The rest of you observing is just fine, like I said before. All right, so we are going to start right in by talking a little bit about what vitamin C, what foods have vitamin C in them, and then we'll do this lab because the lab is focusing on vitamin C. So what do you think of when you think of foods that have vitamin C in them? What food is there? Nyla?
I think of oranges and mangoes.
Yeah, oranges, mangoes are great. Yep. Anybody else? Wick.
I think of lemons.
Lemons, yeah, lemons. Any citrus fruits like oranges, lemons, limes, grapefruit, those all have vitamin C. People do think a lot about oranges, but actually there are other foods that have way more vitamin C than oranges do. Do any of you guys eat guava? So guava has about 5 times as much vitamin C as an orange does. Even kiwis have twice as much vitamin C as an orange. Bell peppers have, like this one right here, this red pepper, they have about 4 times as much. Even something like parsley or thyme, those are spices that you might use. They have 3 times as much as an orange. So don't just think oranges. There's a lot of vitamin C in an orange, but there's food, or vitamin C in a lot of fruits and vegetables as well. So do you guys know anything about vitamin C, what it does for your body? Why do we need vitamin C anyway? How does it help us? So basically, one thing vitamin C is really good at is protecting against infection. That's why a lot of times when people want to stay healthy, they'll take vitamin C or they'll make sure they eat vitamin C rich foods. Also, when people start feeling a cold coming on, if you can take some extra vitamin C, sometimes it can help the cold to not come on. You can prevent a cold. It also keeps your skin healthy. It keeps your gum healthy. It even keeps your blood vessels healthy. It maintains the strength of them. All right, so we're going to do this lab now using vitamin C, starch, iodine, and some drinks that we think might have some vitamin C in them to compare the different drinks. Now, just a reminder of these 3 terms: solute, solvent, and solution. So a solute is like the powder that would go in something. When you make lemonade, the lemon juice that you put into the water is the solute. When you make tea, the tea that you sprinkle into your water, that's the solute. Then the solvent is the liquid that you're mixing it into. So a solute plus a solvent equals a solution. So if you hopefully if you're not doing the lab, you at least read over the instructions. So I asked you when I sent the letter this morning to make some solutions, to make a vitamin C solution and to make a starch solution. You put the starch in the water and that made a solution. You put the vitamin C in the water, solute plus solvent equals solution. AC.
Is the starch solution supposed to look like this?
Yeah. Yep.
Okay.
That's just about right. Yep. Depends on what, did you make yours with liquid starch? You mix liquid starch with water?
Yes.
Yeah. Yep. That's very good look for it. All right. So let's talk a little bit about this vitamin C. So vitamin C has this right here, C6H8O6. It's called ascorbic acid. And when ascorbic acid right here, the vitamin C, is mixed with iodine, which is I2. So it'd be two iodine molecule or atoms that are bonded together into an I2 molecule. It's an oxidation reaction. You don't need to remember what that is right now, but what that means is it breaks down. All these atoms rearrange to make this one, which is dehydroascorbic acid. You can see why it's called that. If you look here, this is ascorbic acid. Well, look what happened. Two hydrogens were taken off. So now it is dehydro. It's been dehydroed, two of the hydrogens off. And where do those hydrogens go? Right here. They bonded with the iodine to make this hydroiodic acid. All right. Now, one of the changes that happens when this chemical reaction takes place is that iodine loses its color. So this reaction is what we call an oxidation reaction. What you need to know is before the reaction right here, the iodine is dark colored. After the reaction, it's colorless. Doesn't have any color. So take a look at this right here. This is the tube on the left. This one here, that's our control. It does not have any starch in it. This one is our experimental and it has starch in it. Now, when you put the iodine in, it turns a dark blue or a brownish color when there's starch. But here's the thing about iodine. It likes vitamin C better than starch. So if there's vitamin C and starch together, the iodine is going to react first with the vitamin C. And then when the vitamin C is gone, then the iodine will react with the starch. So what happens if we put iodine in a solution that has both starch and vitamin C? What's going to happen is the iodine is going to have a reaction with the vitamin C first, and then it's going to react with the iodine. So what we're going to do now is use this information in order to figure out how much vitamin C there is in the drinks that we are going to be testing. The more iodine it takes to use up the vitamin C, the more vitamin C there was in that drink. So we're going to figure out the content of 5 different juices, the vitamin C content of these 5 different juices, and we're going to figure out the vitamin C content of a vitamin C supplement. Now, there's some things that you need to do before you start any science experiment. What are they? Give me an idea of what you need to do before you start any science experiment. Anybody? Hypothesis? Yeah, a hypothesis often comes in. I'm thinking more the preparation to get ready to start doing an experiment. Safety. Yeah, that's it. We have to focus on safety. So here are some things right here that we need to make sure we know. First of all, we have to understand what we're doing. And for that, you have to read the instructions carefully. Know what it is that you're going to do before you ever get started doing it. Then comes in the hypothesis. That's where that comes in. That's part of knowing what you're going to do. The next thing you always want to do is gather all of your materials and all of your equipment. So you have everything. You don't want to get into the middle of a science experiment and say, oh, I forgot to bring water. I can't do this experiment now. I have to get up and go and get more water. So make sure you have everything that you need. So the materials are the things you're going to work with. And then, of course, the supplies are things like your test tubes or your cups or your droppers, those kinds of things. Number 3, safety preparation. So this would be where you would protect your clothing if you're working with something that might damage your clothing. You want to protect your eyes with your safety goggles. Sometimes you want to wear closed-toed shoes and gloves. My sister works in a lab and they're not allowed to wear short pants, even ones that show a little bit of your bottom of your leg. They have to wear long pants because anything that gets on your leg could do some damage to your skin. So you also need to know how to handle the chemicals that you're working with. Like, for example, we're going to be working with iodine today. Iodine is not dangerous, but that's fine. Iodine is not dangerous, but if it gets into your eyes, it could burn a little bit. It could do a little bit of damage. It could hurt a little bit, and it certainly is going to stain your clothes. So you want to know that about everything that you're working with. Our vitamin C solution, our starch solution, those are perfectly safe, but the iodine will stain. You also want to know about safety procedures if there's an emergency. So you want to know where like fire extinguishers are if you're working with fire. You want to know where eye wash stations are. For you guys, it's your kitchen sink. You want to know where your first aid kit is located if you're working with something dangerous. We're not today, but when you do a lab that you want to be aware of those things. You want to check for potential hazards, things that could be dangerous, that could be flammable, could be sharp. Could be something that would corrode. Like if we were working with acid, we would want to be very careful and always making sure that the area around us is safe too. So don't try to do an experiment on top of a crowded desk. Clean your area off first, and then prepare for documentation. So this is where that lab sheet that I sent you guys comes in. You want to make sure that you have your lab sheet out and a piece of paper because you'll be writing some things down on that last page, on that chart of the lab sheet. And when you do a lab, you want to take really good notes. You want to document everything. You want to document the things that turned out the way you thought they would, as well as the ones that didn't. So when you follow all these steps, everything listed here, you'll help to reduce the chances that you'll have an accident. You'll make sure that your experiment runs the way it's supposed to, and that your results are pretty reliable. All right, so the very first thing that we wanted to do is make sure we have everything that we need on this list. Now, we probably don't need these plastic spoons. We didn't use those yesterday in class, so you probably don't need those, but you do need everything else that's on there. All right, we're going to read through the procedure completely before we start it. So those of you who are doing the lab, just watch and we'll go back to it. So there are 3 parts to this lab. There's the starch and iodine test, the vitamin C and starch test, and then the juice comparison test. So the first thing we're going to do is our starch and iodine test. We're going to place 25 drops of tap water into one of our small cups. Then add 2 drops of our starch solution, which you've already made. Add 1 drop of iodine to the cup and look at the color of the mixture. Then we're going to set that aside for comparison later. Our second part, this is the vitamin C and starch test. We're going to place 25 drops of the vitamin C solution that you made earlier into another cup. Add 2 drops of that starch solution, then 1 drop of iodine, and then swirl it. We're going to continue adding iodine 1 drop at a time, swirling after each drop until we get a dark blue color similar to the color we got in part 1. You're going to count how many drops of iodine it took. So those of you who are doing it, you'll count how many you do. Those of you who are watching me, I'll tell you how many drops I put in. Okay? And then we are going to do part 3, which is the juice comparison part. We're going to start with the fresh orange juice and put 25 drops into the cup, add 2 drops of starch and 1 drop of iodine. Swirl. Then we're going to keep adding iodine 1 drop, I should say 1 drop at a time, swirling after each drop until you get a color similar to the one you got before, and count the number of drops. Then we'll repeat it with all the other beverages. All right, so let's do step 1 now, part 1. Okay, so we're going to place 25 drops of tap water into 1 small cup. Now, this is all on your lab sheet that I sent you, all these instructions. So be looking at them. I'm going to turn this screen share off now. I'm going to tip down my camera so you guys can watch the experiment as I do it. Okay, There we go. Here I have, this is going to be the first test. This is going to be my vitamin C test right here. All right. So let me pin that so that you guys can see it really well. Pin. Okay. So hopefully that's nice and big for you. All right. I have my vitamin C solution right here. I have my starch solution right here. And I have my iodine right here. And I have these droppers in there because I want to make sure I use the same dropper every single time. All right. I don't understand what you mean. My say vitamin C. All right. Somebody sent me a message. I need a little more clarity on that message. So type it again if you can. Okay. Now, the first thing I'm going to do is put my tap water that's right here. I'm going to put 25 drops of tap water into my small container. So this is my container. I'm going to count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. All right, I have 25 drops of just plain tap water in here. Now I'm going to add 2 drops of my starch solution. That's this one. You ready? 1, 2. 2 drops of starch solution. Now watch what happens when I put 1 drop of iodine into this cup. Put it right here so you guys can see it. 1 drop of iodine immediately turns that into a bluish brown color. All right. It looks a lot browner on the video. When I look at it myself, I don't know why my camera does that. But it's very, very dark, like dark blue, almost black when I'm looking at it. So that's what color you should be getting in your solution. Okay, now we'll set that aside. That's a comparison. We're going to set that aside to compare later. All right, now the next thing we're going to do is our vitamin C and starch test. All right, so using a fresh cup right here and a fresh dropper. This is my vitamin C. I'm going to place 25 drops of vitamin C solution into this other cup. Let me go ahead and do that. It's 25 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I'm going to get more. 21, 22, 23, 24, 25. All right, I have 25 drops of the vitamin C solution that I made in this cup. Okay, if you're doing this and you need a little more time, let me know. Okay, just type. I can't see all of you, so type it in there. All right, I'm going to move these two aside so that we can have a little more space in the middle. This is my vitamin C. Next, I'm going to add 2 drops of the starch solution. Ready? 1, 2. 2 drops of starch solution. Now I'm going to put 1 drop of iodine. Look what happened when I put 1 drop of iodine in the one that just had water. Now I'm going to put 1 drop of iodine in the one that has the water and the vitamin C and the starch. And watch what happens when I swirl it. It's gone. That was a chemical reaction that just happened where the iodine lost its color because it changed into that, hydroxy iodine or yeah. Let's add another one. That's 2. I'm going to swirl it. Gone. All right, 2 drops. Put a 3rd drop in, 3, and swirl. You see, it's taking a little longer each time to swirl it, but it's still clear. We've still got that chemical reaction happening because there's still vitamin C in there. That was 3. Let's do another drop, 4. It's taking a bit longer, but it's still clear. That's 4 drops. 5. Oh, now it's not clear anymore. You see that? Took 5 drops to change. Now their vitamin C is gone. At this point, the vitamin C is gone. I'm going to put 1 more drop and see what happens with this 1 more drop. That's 6 drops. Yep, now it's the same color as my original, as my control. All right, so that is 6 drops that it took for this one. Okay, record the number of iodine drops, 6. All right, now I'm going to stop this for a second. I'm going to share my screen again. Okay, AC.
Mine's still clear after 8 drops of iodine.
Okay, keep adding until it's not. Keep adding. All right, Isa.
On my uh lab sheet, it says for part 1, put 25 drops of vitamin C.
Yeah, I sent one this morning. I sent a new one this morning in the message that I sent you guys. I told you there was an error on part 1. If you are not getting my messages first thing in the morning on the day we have class, please make sure that you go to the course information and do the one that says urgent at the very top. I'm going to show you exactly what I mean so that we're sure we all get those messages. So let me get this on because this is really, really important. I sent you the wrong lab sheet yesterday, so I sent a new one out today. And the new one has just the, you know, it doesn't have the vitamin C solution. Okay, so I'm dragging this over now. Everybody can see this? Can you see the AIM Academy page? Yes, okay. So when you go right here to assignments, at the very top of the page here, it says urgent. Please watch this video to confirm your email address. If you click on that, it will open up a video that you will see that you need to confirm your email address, because until you do, you won't get any messages sent to you through Canvas. Okay, so you have to make sure that you do that. Please do that immediately as soon as class is over. Okay, so the first one that I sent you guys, the first lab sheet, this step 1 was wrong. This was incorrect. This is the correct one. Okay, thank you, Isa. That was important. I'm glad you brought that up. AC.
Mine took 14 drops of iodine before it disappeared.
Okay, cool, cool. So what you're going to do, look at this chart right here. Under the vitamin C, how many drops of iodine? You're going to put 14. All right, mine was 6. So I'm going to put a 6 right there. Whoop, I don't know why that does that. AC, you're going to put 14 for yours. All right, now what I want you guys to do, look at your fresh orange juice, bottled orange juice, apple juice, sports drink, and fruit flavored drink. I want to rank them. We're not going to rank these 2 right here, but I want you to rank them according to which one you think has the most vitamin C. So whichever one you think has the most vitamin C, put a 1 next to it. Whichever one you think has the least vitamin C, put a 5 next to it. So like, I think that my fruit flavored drink is going to be my number 5. That's going to be my guess. So you're going to pick number 1, and then the next most, and then the next most, and then the next most, and then the least, 1 through 5. All right. So what we're going to do next after we rank these is we are going to test the drinks. As we test them,
James Bond undercover.
We will complete this column, and then we'll talk about this.
Yep.
AC, you're not muted. You can mute, that'd be helpful. Thanks. So you're going to put down the number of drops when we test orange juice, apple juice, sports drink, and fruit flavored drink. Okay, so we already did the vitamin C. We know that it took for AC 14, for me it took 6. Whatever it took for you, write them down. In order for that iodine to completely react with the vitamin C and start reacting with the starch. So it's going to take more drops to react with a solution that has more vitamin C in it. It'll take fewer drops to react with something that doesn't have as much vitamin C in it. All right, now let me, okay, so let's go ahead and do our step 3, part 3 comparison test. So I'm going to do this again. I'm going to tip my screen down. and stop the share so that you guys can see it. There we go. I'm going to move this one out and move this one in. So my number 1 here is my fresh orange juice. Number 2 is bottled orange juice. 3 is apple juice. 4 is a sports drink. I use Propel. And 5 is a fruit flavored drink. Okay, now, the first thing I'm going to do, each of these has 25 drops in it. So that I asked you to prepare that before class. If you didn't, you can still do it now. Just start with your fresh squeezed orange juice. 25 drops of fresh squeezed orange juice is in this one. Now we're going to get the starch solution. That's right here. My starch solution. And I'm going to put that right there, my vitamin C solution. And I'm going to move my key right here. All right, starting with the orange juice, I'm going to add 2 drops of starch solution. 1, 2. All right, now I have orange juice and starch solution in this. I'm going to do the same thing I did with part 2. I'm going to add my iodine 1 drop at a time, swirling until I get this same color, the color that I got here. Okay, so here's my iodine. Bring that in. I'll put that right. Well, I'm going to put it right here. So that's my iodine. So I'm going to count. 1. Okay, that's gone. It's the same color it was when I started. 1, 2. It's taking longer to swirl this one. But it did go away again. It's still that same orange color. 3. This isn't going away now. And that's pretty close to what I had here, to my control. See the 2? Whoop, spilled that a little bit. See the 2? They're very close in color. So that took 3. So on my chart, those of you who are doing mine, on your chart, next to where it says vitamin C, fresh squeezed orange juice, for the number of drops, you're going to put 3 because that's what it took, 3. AC. Oh, your hand was up. Okay. All right. Now I'm going to do the orange juice that is from the bottle. And let's see how many that takes. Once again, I'm going to add my 2 drops of starch solution. 1, 2. Swirl that around. Now I'm going to add my iodine 1 drop at a time. 1.
Which solution are you doing?
I'm doing my bottled orange juice. So 25 drops of bottled orange juice, then 2 drops of the starch solution. And then 1 drop of iodine. Okay, so it took that 1 drop. I'm going to put in a second drop and see. Second drop. Look at that. It's not changing color. We've got that dark blue, almost black color. All right, so the bottled orange juice only took 2 drops. What that means is the fresh squeezed orange juice had more vitamin C than the bottled orange juice did. But not as much as the just tablet of orange juice. That took 6. So for this one, for the bottled orange juice on your chart, you're going to put a 2 because that's what it took, was 2 drops in order to turn it. All right, next I have apple juice. So I'm going to do the same thing. 25 drops of apple juice, 2 drops of starch solution, 1, 2. Now I'm going to do my iodine 1 drop at a time. 1. Clear. Okay, that has some vitamin C in it. 2. Gone. You guys can see the chemical reaction happening here.
Which one are you doing?
I'm doing apple juice now. Look at that, 3, and it's clear. 4. That's not turning now. Just barely. So I know that my juice, my vitamin C in that apple juice is used up with number 4. I'm going to put another drop and see what color, if we get that original color. Yep. All right, that's very close now to the control.
Mine turned green on the first drop of iodine.
Okay, so your brand of orange juice doesn't have as much vitamin C as the one that I did. Mine is Juicy Juice, apple juice. Yep, that's what I have. 100% apple juice. So Juicy Juice apple juice has it has actually more vitamin C than my Simply Orange bottled orange juice does. That's interesting. All right, so next to apple juice, for number of drops, if you're using mine, you're going to put 4, because it took 4 drops to turn it to the color that the, to use it up. Next, I'm going to do my sports drink, number 4. And we're doing the same procedure with all of these. So for number 4, I'm going to put in, I've got 25 drops of my sports drink here. This is Propel, and it's clear. I'm going to add 2 drops of my starch solution. 1, 2. We'll see how much vitamin C Propel has. I'm going to do 1 drop at a time. 1. Yeah, there's no vitamin C in Propel in this sports drink. It's not using it up at all. That is the same color that it's actually even a little bit darker than my control was. All right, so the Propel, you're going to put 1. It took 1 drop next to the sports drink. And then finally, I have my fruit flavored drink. 25 drops in the cup. I'm going to put 2 drops of the starch solution. 1, 2. And swirl it a little bit. And let's see what happens with 1 drop of iodine. 1 drop of iodine. Think about what you think is going to happen. Can't get that to go away. Yeah, none. So 1 drop you're going to put next to the fruit flavored drink. There's 0 vitamin C in the sports drink or the fruit flavored drink that I have. All right, so what I've done now, I'll give you guys a minute, those of you who are still doing it. So what I've done is I did my fresh squeezed orange juice, and that took, I think I said 4, I don't remember. You guys will have to tell me. The bottled orange juice took 2. The, let's see here, this was the apple juice took the most. That took 4 drops. And these 2, only 1. They changed. The sports drink and the other one took only 1. Okay. Anybody have any questions about the lab itself? Back up so I can see you. You can see me. And let's share my screen again. Okay, so that was our comparison test. Now let's look at our chart and talk about the predictions. Or talk about our results that we had. Was anybody surprised by anything? Anything unusual that you saw? Not really. I thought it was interesting that the bottled orange juice or apple juice had more vitamin C than the bottled orange juice does. That was pretty interesting to me. And I also think it's interesting that the sports drink doesn't have any vitamin C in it. I would think that that would. All right. Now, fruit drinks are sometimes really highly fortified. Sometimes fruit drinks like the apple juice and the orange juice will have some vitamin C in it. And in fact, if I look at the label on the back of my apple juice right here, I can see that it has apple juice from concentrate, water, ascorbic acid, vitamin C, and citric acid in it. So they've put vitamin C in this. That's why it had more than the orange juice, where the orange juice does not. If I look at the label on the back, the orange juice has just orange juice, just fresh squeezed orange juice. That's all that's in there. So that's the reason why that the apple juice has more. All right. So anybody who did it, whether you did it or not, take a look at the predicted rank, what you thought was going to happen, your 1, 2, 3, 4, and 5. And then let's figure out the actual rank. So number 1 is going to be the one that took the most drops. So in my case, it was going to be this apple juice, number 1. Then the next was the fresh orange juice. That was number 2. The bottled was 3. The sports drink and the fruit flavored Tide. I don't know why that does that. That's really bad, those lines. So let's try it again. So my actual rank was 1, 2, 3, 4, and 4. All right. Did anybody get a different ranking than that? All right, cool. So let's talk about this a little bit. What was the purpose of the test of the mixture of just starch and water, the one we did first, very first step? Why did we do one where we just mixed starch with water and put in an iodine, a drop of iodine? What was the point of that one? Click.
So that one could compare to the other ones.
Yeah, exactly. That was our control. That shows us what happens when iodine mixes with starch. That was our control group, so that we could see when the other ones turned a similar color. All right. Now, what was the purpose of the second one? The one where we tested the starch water with the vitamin C. What was the point of that? AC.
To see if any of the mixtures we had were more than 1,000 milligrams of vitamin.
Yeah, very good, to see if they contained more or less vitamin C. What we wanted to do was we wanted to observe that reaction between iodine and vitamin C, and then iodine and starch. Remember, iodine will only react to starch once it's already reacted with all the vitamin C, right? So we saw when that was going to happen. All right. What do you think caused the difference between your data in those two tests? Well, it would have been what's different in the experiments. We had go ahead, Wick.
It was that we had vitamin C, and the vitamin C didn't let the iodine react with the starch because
Exactly.
the iodine wanted to react with the vitamin C first.
Right. Think of it as like the iodine likes vitamin C better. It wants to react with it first. It'll only react with the starch when all the vitamin C is gone. All right. Now, why did we have to add the same amount of starch, 2 drops, to every one of these beverages? Every time I added 2 drops of starch. Why? Why didn't I add 3 to 1 and 4 to 1 and 1 to 1? AC.
That way it's controlled.
Yeah, it's controlled, right? Exactly. We have to keep all of the factors controlled except the one that we're changing. The only thing that was changing in these 5 different beverages that we had was the amount of vitamin C. If I had used a different amount of iodine or a different amount of water or a different amount of starch, it would have been different. So I needed to keep that exactly the same. All right, what would happen if someone forgot to add the starch to the beverage before they began adding iodine? What do you think? What would happen? Well, think about the experiment with no starch in it. If it was just juice, just one of the juices, what would happen? There wouldn't be any starch for it to react with. So it would continue reacting with the vitamin C that was in that beverage until the vitamin C was used up. And then it would start turning into an iodine color. That's what we would see, is the same color as the iodine, a little weaker and a little weaker. That's what we would see happen. All right. Of the 4 drinks that you tested, actually we tested 5. Of the 5 drinks that we tested, which took the most drops of iodine before changing color? You guys tell me which took the most drops. AC.
The vitamin C water.
Yep, the vitamin C water for sure, because it had the most vitamin C content. And then the fruit juice that was the highest was the apple juice, which took the fewest drops. All right, somebody besides AC. You're not going to make AC and Wick do all the work. I don't want to call on you guys, but I will. Nyla, thank you.
The fresh squeezed orange juice took the most.
The fresh squeezed orange juice took the, well, actually in mine, the apple juice took the most. It took 4 drops where the fresh squeezed orange juice only took 3.
I think I wrote mine wrong.
Oh, okay. Which took the least?
It was the fruit flavored drink.
Yeah, and the sports drink. They both only took 1 drop. They had no vitamin C in them. So they had the most. All right. So of everything that we tested, except the vitamin C tablet, which one had the most vitamin C? Nyla.
The apple juice.
Yeah, the apple juice. Which had the least? Wick.
It was a sports drink and the beverage or
Yeah.
like,
The fruit flavored beverage. Yeah. How do you know?
we know because they took less drops of iodine, and
Right.
since they took less drops of iodine, they didn't have any vitamin C to react with for it to like not color change.
Exactly. Exactly. All right. The next one. When we tested orange juice, the color of the first few drops of iodine faded away. What do you think happened to the iodine? Oh, we put the drop in and I swirled it and it became clear. What happened to the iodine? Nyla.
It reacted with the vitamin C and turned into a different substance.
Absolutely. Absolutely. We can see that happening right here. Here we have our vitamin C, our ascorbic acid. Here we have our iodine. We don't have vitamin C on this side, and we don't have the same iodine. We have hydroiodic acid here. So it's a different color. It's a completely different color in that reaction. Yep, very good. If a beverage scored low in your test for vitamin C, does that mean it's not good for you? What do you think? Quick.
It doesn't not necessarily say that it's not good for you because vitamin C is found in other places too. Like if you have this in your diet, it could have other nutrients that you need, and then you could have vitamin C from somewhere else.
Yeah, absolutely. Absolutely. All those are other factors that can make something either nutritious or take away. So it might have, something might have a lot of vitamin C in it, but it also might be really high in sugar. And that would mean that it wasn't as good for you. Yeah, you're right, Cheyenne. Protein or carbohydrates can also make things nutritious. Absolutely. Absolutely. All right. Thinking about the way we just did this experiment, I want us to think about a way that we could design an experiment to find out if the vitamin C content of orange juice changes over time at different temperatures? How could we run an experiment to find that out using what we did today? Nyla.
We could have orange juice in separate little containers and put some in the fridge, some just out or like heat some up, and then do the same experiment we did today.
Perfect. That's exactly right. We could test all three of them and see if temperature made the difference. Excellent job. All right. The experiment is over. Anybody have any questions about this experiment? It's kind of fun to do yourself and watch that color vanish as you swirl in the drops of iodine. So I do recommend that you do this on your own if you weren't able to do it today. But you do not have to submit your lab sheet to me. That was just for your use during class. So what we've been talking about here is carbon chemistry. Vitamin C has carbon in it. Once again, let's look back at that vitamin C right here. This is vitamin C. There's the carbon. There's carbon in vitamin C. It is a carbon compound. It is what we study when we study carbon chemistry. So another term for carbon chemistry is organic chemistry. You'll hear them both used. Something, in order for something to be organic, it has to have carbon in it. We don't use the word organic the same way in science that we do in like shopping. When you see organic apples, that means they haven't been sprayed with chemicals. When we're talking about organic in chemistry, we're talking about something that has carbon in it. So last week, you guys learned about 4 major carbon-based macromolecules that living things need in order to survive. So macro means big. What are those big 4 major macromolecules that living things need? Anybody remember? There you go, Cheyenne, good. Protein, carbohydrate, lipid, and nucleic acid. So nucleic acids make up DNA, RNA, ATP. Those are the DNA and RNA are the molecules that are inside your nucleus of your cells. So inside every cell in your body, there's this nucleus that has your genetic material, your chromosomes, your genes. Those are made up of nucleic acids. Carbohydrates are things like sugars and starches. Lipids are fats, and proteins are amino acids that all link together like beads on a string. Now, they're big molecules, so we call them macromolecules. We also have some micromolecules or micronutrients. These are needed by people, but they're needed in much, much smaller amounts. So we call them micronutrients. We don't need as much of something like vitamin C as we do protein. Now, there's 2 kinds of micronutrients, vitamins and minerals. Vitamins are carbon-based. Minerals are not. We call them organic. We call the vitamins organic because they all have carbon in them. They also have hydrogen and oxygen in them, which again, we can see if we take a look at this right here. There's the hydrogen, there's the oxygen. They are all vitamins are going to have carbon, hydrogen, and oxygen in them. They might have some other things in them as well. So let's look at how many we need. Certain vitamins and minerals are needed for the body to function. There are 13 that we need in the vitamin category and 22 minerals. So let's look at the minerals first. Right here, you can see the ones that we absolutely have to eat. These are essential. These are in purple on this periodic table. So minerals are not organic. They don't have carbon in them. So they are they're often things that cannot be broken down, and they're found in soil. So some of the minerals that we need for health are things like calcium and phosphorus and potassium, sodium, chloride, that would be salt, zinc, copper, manganese. Those are minerals that we need. Now, the ones that are in green here are suggested for use in humans. These are the elements that we we're better off if we have a lot of these in our diets. All right, now let's look at the vitamins. There are two different kinds of vitamins. There are water soluble and fat soluble. The water soluble vitamins can dissolve in water. And they're ones, because they can dissolve in water, you urinate them out every day. So you need to eat them every day. You need to get these water soluble vitamins. Fat soluble vitamins can be stored in the body. So they don't have to be consumed every single day because your body can store them to a certain degree. So here is a kind of a list. It's not all of them, but a number of them are here. So vitamins are A, several B vitamins. There's more than this one, more than these. And then C, D, E, and K. So anybody know which ones are the fat soluble vitamins? Of this list here, which ones are fat soluble? AC.
The meats.
I want to just know the vitamin itself. All right, so the fat soluble vitamins are vitamin A, D, E, and K. So there's B12 is found in meats, but that's not a fat soluble vitamin. So there are fat and water soluble vitamins in a lot of foods. All right. So these, all these right here, these are water soluble, these B vitamins and vitamin C. Now, remember that these pictures like this they're often the way that we represent carbon in molecules. So this is a carbon ring structure, and they are often represented as a regular polygon, a shape that has a bunch of sides on it. And right here at each apex, there is a C. So if you look at this one, this is a vitamin C molecule. Each of these apexes right here, and right here, these would be carbon. There'd be a carbon molecule right there. So if nothing else is labeled, like this is an O, that's oxygen. If nothing else is labeled, we know that it is a carbon right there. And this is the chemical structure of all the vitamins. Now notice they all have carbon, hydrogen, and oxygen. Some of them have other things as well. So let's take a look. Let's zoom in just a little bit on, oh, I have to turn that off. Whoop, there we go. Okay, let's zoom in on B12 right here. So you can see there is some nitrogen in the B12. All of these rings would be carbon. That's how complicated this vitamin is. This is an important vitamin for your nervous system, for making red blood cells and making DNA and RNA. We can move these around and look, this is vitamin D. This is our vitamin C right here that we were looking at right there. Really important for your immune system to work properly. All right, and we are done now. We got it all the way through. Anybody have any questions about the experiment we did or vitamins or carbon chemistry? I think carbon chemistry is pretty cool. Organic chemistry was my favorite class in school, in college. I loved it. All right, if you don't have any questions, you are free to go. Have a great week, everybody, and I'll see you next time.
Thank
Bye,
you.
everyone.
Goodbye.
Thank you.
Thank you.